All right, so in this first part of chapter 6, the first couple of sections, when we're talking about the triangles that we're talking about, we're going to be talking about oblique triangles. And that just means that we're not talking about triangles with right angles. So we don't have right angles in our triangles. We're going to be talking about oblique triangles. And just as a reminder, solve means when we're talking about triangles, we're finding all the missing parts. So let's draw a triangle. We'll remember how we label triangles, and then we'll write our law of sines, talk quickly about why it works, and then do a couple of problems. So when we label triangles, our capital letters, capital A, capital B, and capital C, are angle measures. And then we write small a across from the angle, B and small c, those are the side lengths. So this is how we label our triangles, how we'll do this all throughout the entire chapter. When we're talking about law of sines and law of cosines, we want to be in degree mode. With triangles, we're usually almost always working in degrees. So the law of sines tells us A over sine A equals B over sine B, and that equals small c over sine C. Or we could write it the other way around. We could do the reciprocals of all of these. Sine A over A equals sine B over B, and then equals sine C over C. And I usually use the top version if we're looking for sides, to solve for a side, and I would use the bottom version if we're solving for an angle. But it doesn't really matter. They're both the same. So there's our law of sines. Nice, easy formulas. Not difficult to remember. Not particularly difficult to use. And those problems in chapter 4, when we had to set up two triangles and set up simultaneous equations, that kind of thing, with law of sines, makes that kind of problem way easier. All right, and we're going to use law of sines. You notice that in order to use one of these equations, we either need two angles and one side, or we need two sides and one angle. So we're going to use these for we're going to use them for angle side angle triangles. We're going to use them for angle angle side triangles, and we can also use them for side side angle triangles, but we'll talk about those separately tomorrow, because we end up with a special thing we have to deal with the side side angles. So we need either two angles and a side, or two sides and an angle. All right, and so because we don't want this just to be some magic formula that we use, we want to have an idea of why it works. And the law of sines, the reason it works is pretty easy now that we understand right triangle trig really well. So let's talk about why it works. It's a really easy idea. So here's my triangle. This is A, B, C, my generic triangle for this chapter. And what we're going to do is draw in an altitude for this triangle. So perpendicular from one side. And we'll call that H for the height. And if we look at this right triangle on the left, we can find the height. The height equals C, small c, sine A. This is the opposite, and this is the hypotenuse. So the height equals C sine A. If we look at this triangle on the right, the height equals A sine C. So C sine A equals A sine C, or A over sine A equals C over sine C. So I just divide both sides by sine A, divide both sides by sine C, and I get one of the equations that's in the law of sines. Sine A over A equals sine C over C. And if I wanted to get the other equations, I would just draw in another altitude and do the same thing with the other two sides and the other two angles. And I would get another set of equations. So law of sines works because we divide our triangle into two right triangles, and the heights, these two heights have to, or the height has to be the same no matter how we find it. So nice, easy idea where the law of sines comes from. All right, questions there? Okay, all I want to do is go through a couple of quick examples of using the law of sines. So we're going to use them for angle side angle, angle angle side, or side side angle. We'll talk about the side side angle triangles tomorrow. So let's go through a couple of examples. So let's say that A equals 123 degrees. Angle B is 41 degrees. Side A equals 10 inches. And we want to find side C. So when they don't give you a picture, always draw a picture. And if the picture isn't the kind of picture you like, you can always relabel your angles and sides. I always like to say, draw the triangle like this. So if they give it to you, if they give the triangle to you in a different way, you can always just rename your angles and just make sure you find the appropriate one at the end. So this one is 41 degrees, and this is 10 inches, and we want to find side C. All right, so what piece of information are we missing here to use the law of sines? I'm going to say sine A over sine A equals C over sine C. We need angle C. How can we find angle C? 180 minus the other two angles, right? So angle C is 180 minus 123 minus 41. And that tells me that angle C comes out to be 16 degrees. And now I can set up my law of sines. I can say C over sine 16 degrees equals 10 over sine 123. I always wait to plug these numbers into my calculator until the very end. So I'm going to multiply both sides by sine 16 degrees. So I get C equals 10 sine 16 degrees over sine 123 degrees. Plug that in my calculator. Just to be safe, I would put parentheses around here to make sure everything calculates correctly. And when I plug that in my calculator, I get about approximately 3.29. Now, if you plug these numbers into your calculator here in the intermediate step, keep 4 decimal places, because if you round these off to like 2 decimal places, it can really make a big difference to your final answer. So if you do this, if you plug the sine of 16 in here and sine of 123 in here, keep 4 decimal places. What's that? Right. That's why I usually like to plug it in. So I would just plug it in the calculator exactly like that. So nice and easy. Plug it in your calculator. Make sure you're in degree mode for law of sines, law of cosines. I think in the majority of chapter 6 we're going to be in degree mode in our calculators when we do calculator stuff. Questions there? Oh, and I forgot to ask one thing. So we started off with angle A, angle B, inside A. So what kind of triangle is this? Angle, angle, side. This is an angle, angle, side triangle. So that's another hint that we can use law of sines. We have two angles and a side across. All right, questions there?
You have to solve the whole triangle right away.
This particular problem just said find C.
Okay.
So it didn't say solve the triangle, it just said find C. But if we needed to find side B, we'd just use the law of sines one more time to find side B. All right, let's look at one other example. Let's say we have a triangular plot of land. Just so we're not saying we have a triangle. And let's say that our angles, we have one angle that's 95 degrees, and C equals 68 degrees, and the side between is 115 yards long. We want to find the lengths of the other two sides. So let's draw our picture. Here's our generic law of sines triangle. We know that A is 95 degrees, C is 68 degrees, and the side between is 115. And we want the other two sides. So we're looking for side A, and we're looking for side C. So what piece of information do we need before we start? We need angle B. And to find angle B, we subtract from 180. So that comes out to be 17 degrees. And then we're set to plug into the law of sines. So I'm going to say, let's find side A first. So A over sine 95 equals 115 over sine 17. So A is 115 sine 95 degrees over the sine of not 117 but 17. Do those just to be safe in our calculators, and I get A is about 391.84 yards, and I just repeat that process to find side B. So I can say, or side C. C over sine 68 degrees, and I can use the same side there. 115 over sine 117. So C is 115 sine 68 degrees over sine of 117. Plug that in my calculator, and I get C is about 364.69 yards.
Would it be sine 17, not 117?
Why I keep writing 117 there. I don't know why. Yes, you're right. That would be an impossible triangle, wouldn't it? All right. And what kind of triangle do we have here? This is an ASA triangle. All right. That's the first part of law of sines. Nice, easy. Questions? Okay. And I'm going to take off some of the homework problems that are on the board there. I'm going to take a couple off. Page 410. So no, take a 10 off. And what I'm going to start something this chapter, and we'll see how it works. For every homework assignment, I'm going to give you 1 or 2 challenge problems. These are optional. And if you decide to do the challenge problem can replace 2 of the other homework problems. So that you don't have to do the challenge problem, but if you do the challenge problem, you can replace 2 of the other homework problems. So the challenge is number 49, and as you might guess, the challenge problems are a little more challenging. All right, so there you go.